Hi, I'm Gobi, and today I'll be talking about rale-rnd. This is a winter 2019 update on my project about sense-making code architectures. So, the users are intermediate JavaScript developers who have done courses or online tutorials in JavaScript but are not professionals who are ready to sell their skills to companies as a craft. So users want to sense make JavaScript code from inspirational examples to learn how to implement things that would make them a professional, and they want to learn programming and design concepts from their favorite sites with the goal of building such features as a professional down the road. Right now, this transition between novice and professional is a rite of passage, and boot camps are not scalable. And one of the big important things to note here is that novices know syntax and canonical examples, but lack JavaScript architecting skills. Now, this point will be further nuanced later in the talk, but right now, what we know is that lessons in application development don't necessarily translate to real-world projects, and so if novices want to learn about how to build features in the real world, current tools are overwhelming and don't really respect their time. So I started this quarter off by looking at other program comprehension literature approaches, and I found that there is a bottleneck in measuring what architectural level understandings have been learned. So essentially what people are measuring are the time to find relevant code for a feature or ability to modify specific code for a certain result, ability to reproduce code features in a sort of fiddle, or questions relating to variable scope, and ability to debug a program or identify certain concepts in code or diagram freely. But these approaches are not quite what is going to get us a deep understanding of whether the learners know the outcomes in JavaScript architecture that we need them to know in order to be on the path towards professionalism. So specifically, I'd like to highlight that there's a balancing problem. Free diagrams allow the learner a lot of freedom, and they're not gradable. So they can express what they know, but we don't know what they don't know, right? And we also can't grade easily what they've said. And so we need to balance that with targeted measures that target specific outcomes. And that act of creating a measure that can balance those two things is non-trivial and requires careful ordering of questions, is what was found. So there was a notion of appreciating nuance in this literature overview. So as I scanned literature on program comprehension, I began to start ideating what could be important outcomes, comparing them with the outcomes that literature had, but for architectural level JavaScript understanding. And I came up with a few. Some of them were how coordinates, like XY coordinates, flow through flow. So it's a data flow concept. And another one was having lazy loading happening. Another one was having a listener bind or unbind another listener. So specifically a listener's callback bind or unbind another listener. And I developed qualitative measures for some of these outcomes after justifying them, of course, and justifying why some of the tools that were built in our lab can help learners achieve these outcomes. And when I designed these measures, I created tiered levels of specification. So first I had them do free diagramming. Then I started asking questions that target specific outcomes. And finally, I provided a bit of structure around how their answer should be. And learners were not able to go back to free diagrams or testing specific concepts once they had moved on to more structured questions. So that way we were able to see what's in their head and then see whether they have what's in the experimenter's head. So we tested measures on 5 users, and the synthesis of these results is still in progress, but we found that learners are able to describe listeners and their callbacks after using our tool, but they are struggling with more complex relationships because the tool tends to be overwhelming. So my arguments for the measures were that we should have a sort of tiered experience. And the reason why that tiered experience is important, from free diagramming down to structured expecting structured responses, the reason why that's important is because we want to see the exact understanding that learners have in the way that they feel is easiest to express. And we also want to know whether they know specific concepts. So only having learners express their understanding in free diagrams could result in them missing important details. So that might be a false positive, or a false negative. Forcing learners to explain in a particular way could lead to false negatives because they may have understood a concept but just not been able to articulate it in the way we want them to articulate it. So we propose these tiered measures to resolve this issue, and learners are asked to proceed linearly, as I described before. The design is a superset of free diagrams. So this design of measures for our tool Isopleth is a superset of the free diagrams that the original Isopleth paper had learners do. So we knew it could work just as well as the original measures, but it would be easily gradable because of concept-specific targeting in other questions other than the free diagrams, and we'd be able to compare our concept-specific answers to free diagrams to sort of debug this transfer from their way of communicating into our way of communicating. And so at this point, I'd like to highlight some of that tiering. So I'm going to follow this link, and you can see some of that tiering over here. So first, we have them do a free diagram in outcome 1, and then we have them fill a table that targets specific events listened for and the relationship between a listener's callback and other listeners. And then we have them diagram in a way that we expect, and then we ask them very specific questions about unregistering and registering other listeners, which could be construed as heavily structuring the learner, but we had them diagram freely before, so we know what they know. Now, another example of this would be over here. First, we ask general questions about where an event gets passed, event object gets passed, and then we start asking more specific questions like specifically mouse coordinate data and what things mean in terms of mouse coordinate data. Another example is asking general questions like where data is being loaded, but then honing into very specific questions like what would happen if all the data was loaded on a page load and events just triggered from a fetch from local storage or cache rather than a fetch from the server. So now we're really structuring them and helping them understand lazy loading much more than the first question was. And so, but we knew what they expressed in the first question's answer, so we allow for both forms of expression in this tiering mechanism. Now, the study that I conducted had a learning goal for the experimenter, me, which was to know how many outcomes the learners know. So I was trying to learn how many outcomes the learners of JavaScript knew and to what degree after using the tool Isopleth. And so this pilot had an introduction session and then intro session with Isopleth, having them use Isopleth on a website of interest and answering questions that are basically our measures, and finally answering meta questions about the tool. And so users did free diagrams, and we found as a result that they're free diagrams are consistent with their responses from the outcomes table. So that was the first table that I had shown. And what's important to realize here is that the tiered levels of measures actually were consistent between each other. The way they diagrammed freely was consistent with the answers they gave in that table where we asked them specific questions and targeted specific outcomes. So free diagrams, all the free diagrams that we saw covered mouse events and relationships, which was great. So they did include details in their free diagrams. And the free diagrams gave us a full picture of what the users were thinking, but they were not as easily gradable, and neither was the talk aloud. The talk alouds were great and gave us a lot of learning details, but they were not as easily gradable as the tables. The users were more descriptive about our specific outcomes, however, when filling the table. So we got that data as well. And so the result was that the first result was that the measures did hone in on what the learners know, what the learners don't know, and to what degree as well. And so they did their job in that. So this result is positive. The second result is that specifically with respect to outcome 1, which looked at listenerception, the fact that a listener can bind another a listener's callback can bind another listener. 2 out of 5 of the participants listed 3 out of 3 of the events that we were expecting them to identify. So in terms of just identification, that was the result. And 3 out of the 5 participants listed 2 out of 3. So in terms of just identifying events that existed, learners did fairly well. However, only 1 out of 5 of the participants actually understood the outcome that we were going for after using the tool. So 4 out of 5 participants were able to articulate that it's important to only track a mouse move under certain conditions, such as when the mouse is down, not up, in order to execute a drag action. However, only one was able to connect that need with the concept of listenerception. That is, that you can have a listener bind or unbind another event or listener. So more results will come in when data has been completely analyzed and more data has been collected, because right now only 1 outcome has been tested, and there's a lot more we could test. We have 4 outcomes and four sets of measures for each of those outcomes. But so far from the data, we found that the tool was not able to help learners achieve complex architecture level outcomes. And the meta questions really reveal why, when the learners articulate exactly why they struggled. So they were overwhelmed by the number of nodes and edges, and they were not clear what triggered top level calls. The entire timeline was not really lined up with their interaction. So we actually got feedback that said that I would really like to hone in on these particular seconds of my interaction with the web page and what that corresponds to in terms of the call graph in Isoplet. And so another learner mentioned that motivation is an issue. It's the experience is completely unstructured, especially in terms of the learner's time, and it's difficult for them to want to keep trying. So it's not really like they're checking off boxes or completing items, and it's not really demand pull as well, at least in our experience, because we're piloting on people who have been asked to use the tool with a certain goal of trying to reproduce an example, but the more granular actions within using Isoplet are not clear. What do I do next? It's hard to keep track of and move between nodes that are connected by orange and purple arrows, which are very important because those highlight asynchronous relationships. And it's hard to figure out what functions are doing. One of the participants did admit laziness to not actually reading the code in the code pane or only skimming it. But the participant mentioned that it's difficult to understand flow of data despite the input and output tabs, because the participant didn't know which run the input and output tab data correspond to. So the tool was, however, helpful, and the participants agreed to this. In fact, they stated it. It was helpful for seeing some function-to-function relationships, the chronology of function calls, and concrete call types. So one user actually did use facets. Unfortunately, the others didn't, despite being introduced to them. And the user that did use facets did find that the nodes were slightly less overwhelming because there were less of them, because they had honed in on just mouse events. However, most of the users didn't use facets despite being introduced to them. And yeah. So one hypothesis that I ideated when looking at the user data, especially the fact that learners saw the need for conditionally tracking mouse move activity, but the learners did not connect that or state the outcome of listen reception. One hypothesis I have is that many of the obstacles towards sense-making the architecture could have been solved by knowing canonical examples and syntax very well. So I'm not saying that syntax lessons will teach them architecture. I'm saying that syntax lessons will make them so literate that piecing together architecture concepts will become very easy. In this case, we may not have to compare isopleth with just CDT or just a procedure of how to use CDT as a control. We would actually have to make our control be CDT plus presentation of tutorials on canonical examples with fundamental JavaScript concepts and syntax. And recruiting people, the one thing I realized at this point was that recruiting people who have very high tutorial or syntax knowledge, but very low architecture knowledge may be impossible. They just aren't a big chunk of the population who it's like expecting people to know a ton of words in the dictionary, but not knowing, not ever having read a book or understood a book. And so again, the analogy to literature is interesting because we would never expect someone to understand a book without understanding the basics of English and grammar, say it's a book in English. But we are expecting them to understand JavaScript architecture without understanding fundamentals of tutorials and tutorial concepts and syntax. Another hypothesis, however, is that the analogy to literature is not correct, and the best way to improve learner architecture understanding is not to improve their tutorial or syntax level understanding, but rather to help them experience examples that teach them architecture. Now, that is more in line with the goals of isopleth, and if that is the case, we do need to make a decision. Right now, it seems like isopleth is scaffolding past syntax unsuccessfully. So either isopleth needs to successfully scaffold past syntax obstacles, because it's not right now, or it needs to teach syntax at the same time. So those are the two options under hypothesis option number 2. So takeaways are that the tool has very helpful attributes. The tool of isopleth has very helpful attributes that we've had learners articulate and state. But it is not a solution for teaching architecture level JavaScript from examples, which is its goal. So the measures that we ideated and tested are able to highlight what aspects of architecture outcomes learners do and don't understand. And the state of the art, one big takeaway is the state of the art control is needed. And it can't just be CDT or CDT plus a procedure of how to use CDT, but it really has to incorporate CDT plus tutorial or syntax tutorials and basic or fundamental JavaScript concept tutorials. Because even when learners went through the cheat sheet and identified specific concepts, so every learner went through a cheat sheet where they identified to what level of degree, 1, heard of it, 2, understand the meaning of it, 3, have done a canonical example on it, for a number of specific terms in JavaScript. And when learners did that, they we got great results. We got results that said that they basically claimed that they knew these concepts. However, they did not understand them deeply enough to achieve the architecture level outcomes that we expected. And so so it is quite important to realize that at that point I had this understanding that, or a realization that it might be impossible to find an intermediate level JavaScript developer who's not a novice, has done some tutorials, but is not an expert either, to have very, very good syntax level understanding, but very poor architecture level understanding, and then build a tool to help them. Because it seems like architecture and syntax come together. And so to tease them apart is not that easy. And we do have to make some decisions, as I discussed, regarding that. Now, further analysis of the study results are needed, and we may find that what I've discussed right now in this presentation is not the most important thing to be focusing on, and it may not be that preventing a deep understanding. It may not be that we could prevent to find obstacles that couldn't have, it may not be that the obstacles that we found can be prevented by a deep understanding of canonical examples of syntax. However, right now it's starting to look like it, based on the data that's been analyzed so far, that perhaps canonical examples of syntax could have prevented the failure to reach outcomes. So we have to decide if our tool goal is to reinforce syntax, or if the tool goal is to scaffold past syntax, all while trying to teach architecture as well from examples. So again, more findings to come. Thank you.